Hey guys, I want to show you an example of the hooked Web3 provider in action. This is an app that I wrote that takes advantage of it. I will go over this app in a second, but I just wanted to go over what the hooked Web3 provider was, so really quickly. To do that, oops, I don't want that. I'm going to go over the code. So the hooked Web3 provider is a normal Web3 HTTP provider that, in addition to taking a host as a constructor variable, it also takes in a transaction signer. Now, a transaction signer is another function or object or entity or device, perhaps, that will sign transactions instead of those transactions being signed by the Ethereum client. So think of it this way: if you have an address that's managed by something else, for instance, your phone, and somehow Touch ID is involved, and Touch ID signs the transaction, that will be able to hook into this Web3 provider and manage that address. If a transaction comes in for a different address that's not managed by the transaction signer, then the Web3 provider will just pass that transaction onto the Ethereum client as if nothing happened. It'll look like normal. If you want to get technical, what it's doing is when there's a transaction that needs to be signed by the transaction signer, it'll actually take the send transaction method, rewrite it to be a send raw transaction, and then have the transaction signer sign it. So I can get into more of those details to anyone, or more of the technical details to anyone who's interested. But let's go to my example. So this example actually uses a version of Ethereum.js accounts that I've edited to be a transaction signer. The hooked Web3 provider expects the transaction signer to talk in a certain way, so to have specific functions on it that can be called. So I've given those functions to Ethereum.js accounts and have how to do the functions that we need. So what I'm going to do is I'm going to start by showing you what we have available. So if you look here, we have a bunch of different addresses. One of these addresses is registered in the Ethereum client, and the rest of the addresses are registered in the browser. What this address specifically means is if you go over here, look at what's going on, is I'm mining with this address in Geth. So since I refreshed the page, I've mined, I should get a bunch of block rewards. If I do refresh balances, you're going to see that balance go up, which it did. So the next thing we can do is I can send Ether from this address, so from the address registered in the client to an address registered in the browser with that's registered via Ethereum.js accounts. So send one Ether. It's going to say transaction successful. Of course, if you look over here, the transaction is registered. It still needs to be mined. What I found is it needs to be mined at least 2 blocks to get a result. So we got our 2 blocks. I'm going to hit refresh, and you're going to notice this balance goes up, which is great. So we sent 1 Ether from a client address to a browser address. Well, now here's where it gets it. Actually, let me step back. That transaction was not interesting. It wasn't interesting because what the Web3 provider did was just say, oh, it asked the transaction signer if it managed that address, and the transaction signer said nope, and so it passed that address onto the Ethereum client, and the Ethereum client did everything like normal. So now here's where it gets interesting. If we swap these 2 addresses, so now if you look, I'm sending from an address registered in the browser to an address registered in the client. Now the 2 address doesn't actually matter. I could send to any of these addresses, but for now I'll just send to this one. And actually, you know what? I'm going to send to a different address just so we can see that the value goes up. So this address actually has no Ether associated with it. So what I'm going to do is I'm going to go ahead and send one ether and so now what's happening is previously we weren't asked for a password because Geth took care of all the signing, but in this case, Ethereum Just Accounts is doing the signing and wants to make sure, wants to ask for the password in order to unlock the private key. Here, the passphrase is passphrase, and that's here by default. So I'm just going to go ahead and click, go ahead and click OK to unlock the account, and what that's going to do is send the transaction. So it says transaction successful, happens just like before. Transaction's right here. It's going to get mined. In fact, it already has been mined, and that actually came back quickly. We have our one ether. So I'm going to go ahead and look at the console just to explain this even further. So what we just did is we took, that should have been a send transaction, and if you look at the code that's that was used, the code that's backing this little app I made, it's just calling eth.send transaction. It's not calling eth.send raw transaction. And what the hooked Web3 provider did was rewrote it to a send raw transaction. So here's the raw data. It's signed by the transaction signer, and everything went through as expected. So from here, we can do something even crazier. So what I'm going to do, I'm going to send a bunch of ETH, because I'm going to need a bunch of ETH to do what I need to do. Oh no, transaction didn't go through. Oh, I see what it did. Well, that's interesting. Known transaction, which means my nonce isn't. My nonce is not correct. Well, I found a nice bug. You know what? I'm going to write this down. What just happened is that I initiated multiple transactions in succession, and the nonce wasn't registered between transactions. Or sorry, the nonce wasn't managed between those two transactions. So it was the second transaction happened at the same. It happened before the first block was mined, and in fact, they probably had the same nonce. I need to double check that, but let me just write that down. Known transaction with Geth. So that's something I got to figure out. I've written a bunch of code with batched calls, which isn't shown here, for the hooked Web3 provider that will manage all the nonces. So basically, I effectively did the same thing as a batched request. I sent two of them in succession, but since they weren't batched, the nonces weren't managed correctly. So, okay, all right. Well, we can continue on. That doesn't matter so much. What I'm going to do, let's see where we're at here. Great, the from address. So now I'm going to deploy a contract. Let's go ahead and clear this. I'm going to. So when I deploy a contract, this is a contract that's just hard coded in here. It doesn't matter so much, but it's going to come from the from address, and the to address doesn't matter. So I'm going to click deploy contract. Again, we get the passphrase because this is sent from an in-browser account. Hit OK, and now before we get any response, it has to mine that transaction, and then we'll get our contract back when it's finally deployed. So there, it's deployed, and notice that we get this test value that says 0. the code for this contract, actually, I'm going to show it to you. Code for this contract looks like this, where basically you set a test value, and then you can read it. So what happened is we created the contract. It starts, test value starts at 0, excuse me, and we can then read it. Now we can execute an example contract function, which is set test value, and change it to 5. So we go ahead and hit that. And passphrase, hit OK. Same thing. Oh, man. Ugh. Okay, all right. Here we have another bug. This one is my own doing. Gas price for executing code is null, which means gas price, oops, this needs to be, okay, we can go through this again. I'm just going to go ahead and click refresh. Let's go back to this account, which has a bunch of ether. We deploy the contract again because we don't have the contract address anymore. We're going to let that go, let that mine. The bug that happened is that the gas price wasn't set correctly when I was executing this example function. So that errored. We need to wait for the contract to happen. Great, we have the contract. Now let's execute the function. Passphrase, we hit OK. And we're waiting for that transaction to go through, which is right here. Again, these are all transactions that have been rewritten to be signed by the transaction signer. And the value is set successfully. We hit OK, and our return value is 5, and things have been set to 5. We can change this to 27. The same thing's going to happen when we when this next transaction goes through. So that's the overview. You had to see a couple bugs go through there, so I have some things to fix. I'm likely still going to show you this video only because it'd be nice to demo something. So cheers. I hope this is useful. So I would love your feedback. Thanks.